Hey, when it's here, yeah, Dana, you're so nice. Hey, are you doing safety? Are you doing safety? Are you doing safety after? Are you doing safety after? You don't know. Dude, this is my attention span is 0 right now. Do you get a little bit of gas here? We're sitting here. Oh no, do you get a little bit of it here? No. Oh, sorry. I'm sorry. Vapor? Okay. You never get a little bit of vapor? Never.
Depends upon how smart you are.
Well, because when I do it on the graph, you can plot it here, and then you can read off the value on the sides.
That's right, you sure can.
But is it accurate? But it's not, right?
It is right. It just isn't what you think it is.
What is it? What am I reading on the side?
That's exactly the right question. You're reading that composition. That is fair.
Got it.
Okay. All right. That's our problem. We're trying to decide what we might do if we can no longer assume equimolar overflow. Now, when we had a problem like this before, what we did was we made a balance around the whole column to begin. So this tells me what D is. So the assigned, the two product specifications tells me D, that tells me B, and that tells me XB if I would like to know it at this point. That's not really the issue. I'm going to make a balance around the entire column, which is going to go something like this. F equals D plus B. CF equals XDB plus XBB. HF plus QD plus QB equals HDD plus HBB. Now we'll draw a the pressure is set. We're given the pressure is set, and therefore we have all the data we need.
Why are you putting Q in the mass balance?
I'm not. This is a total mass balance. This is a component mass balance. That's a heat balance.
Oh.
And I have data where I've got enthalpies plotted. The pressure's been set. I've got X and Y across here. And I've got a product composition over here, XD say. I've got a feed composition here, Z say. And I got a bottoms composition, XB say. And since that's saturated liquid coming out, this point has coordinates XB and HB. There's a feed, and it's got some enthalpy. I don't know what, it might be cold feed, so here's cold feed at Z and HF. And I might have subcooled this reflux here, so the reflux might be coming out at XB and HD. So I guess I've got to be told not only HF, but I guess I got to be told how I'm running that heat exchanger, so I guess I got to be told HD as well. Now, I'm going to adjust this by dividing by D. I'm going to adjust this by dividing by D, which means I got to multiply that by D, which means I got to multiply that by B. Then I'm going to take them over to the other side. So I'll erase these. Right equals right HD minus QB over D times D plus HB minus QB over B times HB. I look at this and I say, amazingly enough, this looks like something. And what it looks like, as we've come to love, is we'll set Z equal to Z and HF. We'll set XD equal to XD and HD minus QD over D. And we'll set XB equal to XB and HB minus QB over B. So these equations simply become one of our favorites. Z equals F times XD plus 1 minus F times XB, where the way I've got this written, F must be D over D plus B. And this we recognize as the lever rule, which we ought to always expect to see anytime we've written things in such a way that it looks like there's some conservation going on. And that means that the point Z and the point XD and the point XB must lie on a straight line. So here's the point Z right here. Here is the point XD right here. Oh shit, I'm going to be down there somewhere. I'd like to move this whole thing up. Anyway, if I do like so, well, it's not so bad. It's just a little crooked. What I've located by doing this is I've located the vector XB, which means having made the balances around the column, I now know QB. So I've made the balances around the column, and the thing I've learned is QB. I already did some of the balances around the column to get this stuff. I didn't have to do that, but I guess it helps. Okay, so what is this QD, you say? Now this point up here has two coordinates. It has a coordinate XD and a coordinate HD minus QD over D. Here's the point whose coordinates are XD and HD corresponding to subcooled reflux. So we're going to pretend like we're given R, because that is the thing people always like to imagine they're given. So we would like to, at this point, relate R to QD. We said a long time ago we could always do that. So let's do that. So
which R?
Which
R? Aren't there two? The one from the top and bottom?
What's R?
No, which one? Aren't there two R's?
I don't see two R's, do I?
For the top and bottom?
There's an R up here, which is defined to be R equals L over D. This is D, this is L.
And the bottom?
Bottom will take care of itself. The bottom, I'm gonna know everything I wanna know about the bottom because I just found QB. But R is L over D, which means that L is RD, and it means that V up there, this is V, is R plus 1D. Now, I've called that L and that D, but that does not mean that any of these L's in here are that L, or any of these V's in here are that V. They're not, they're changing. So I'm gonna make a balance around the top of this and see what I can learn. So here I go around the top of this. So I say something like, what do I need? I guess I need to write V times H plus QD must equal L plus D times HD. And I guess what I'll do is divide this by D and multiply by D. Then the next thing I will do is recognize that L plus D is V. I've got a V here, a D here, and a V here. And V is R plus 1D, so this becomes R plus 1 H minus HD equals minus QD divided by D. So let me put on the diagram where these things are. If this is XD and this is little HD, that right there must be a point whose coordinates are XD and H. This, of course, is saturated vapor of the same composition as that liquid. So this thing is telling me that if I go and look at the difference H minus HD, I can see that easily. Here's H minus HD. If I multiply that difference by R plus 1, I'm given R, so I have R plus 1, I get minus QD over D. Now, I have now traded reflux ratio for QD or QD for reflux ratio. So reflux ratio is the way to go. Then, if I want to find the point whose coordinates are HD minus QD over D, I simply write HD plus R plus 1 H minus HD. That means if I want to locate that point up there, I go to this point here whose elevation is HD. To it, I add R plus 1 times that distance, and I move up here and find HD minus QD over D. So I have that point. I have that point by inputting R. So when I input R, I have QD. Given QD, then we go and make the balance around the column, we get QB. If you wanted to know the boil up in the bottom at this stage, you would make a heat balance around here knowing QB, and you'd be able to find the boil up there if that's what you want. But it's not a big issue because there's nobody in here necessarily whose flow rate is that, and there's nobody in here necessarily whose flow rate is that. But we've taken the first two steps. We've gotten QB, and we've related QD to the reflux ratio 1 to 1. Okay, so we're ready to proceed. Now what we would like to do is make everything look as much as possible like our other construction. That way, it's clear what's going on. So there will be nothing new to learn. So our aim here is, well, I might not want to erase that, but there it goes. So we have this column here we're trying to say something about, and I've set the pressure. So I'm sitting here with a y versus x. And I've got my usual 45-degree line, and I've got my feet on there. There's no earthly reason to put the feet on there. I do have the point up here whose coordinates are x, d, and d. I have the point down here whose coordinates are x, d, and b. Now, in the past, what we did was we put the point on here whose coordinates were z and z. And then we drew what we called a feed line, which was a rough idea of how the flows changed as you move from here to here. In any event, what we really wanted to put on here was the material balance line, and under the old regime, that was a straight line. Then it changed slope and it was a straight line. So clearly what we want to do now, okay, so we got an equilibrium curve on here, which I guess I should hesitate to put on, but there it is. Okay, so our aim ought to be, find the material balance line. Well, in this case, of course, it'll be a material balance line and a heat balance line. And above the feed and below the feed, so we begin. We go above the feed, and I'm trying to put something on here that is the generalization of the line that we used to draw of slope r of r plus 1. So I'm going to do what I did before. I'm going to go there, and I'm going to make the balance around the top. How does that go? The balance around the column down to a stage above the feed, is this. It looks like there'll be a V coming in, carrying in its Y. There will be an X going out, carrying out its L. And there will be a XBD. So we sort of like that. That's an old friend. We also know that V equals L plus D. So that although L and V are changing down the column, the difference V minus L is not changing. That's something we fell in love with when we were doing the extraction cascade. So we write VH equals LH, but there's another input, VH plus QD, which, because I learned that that's something that I ought to write differently, I'll write it differently. It's QD over D times D. LH, what else do I have? I have a D going out and an HD. So I take this and stick it over there. So I erase this. I stick it over here, and I've got D times HD minus QD. I'm looking at this and I'm saying, as no one is surprised, if I set Y equal to Y and H, if I set X equal to X and H, and if I set XD to be what it was before, XD and HD minus QD over D, each 3 points along a straight line. So I go to my data. I've now got a balance of heat and material, which tells me that a certain set of points I'm interested in lie on a straight line. It's the lever rule again. And so I say, okay. I have this data, H or H, at the pressure that's been assigned, and X or Y. And I say, yes, but I had this point up here whose coordinates were XD and HD minus QD. I already used that point to make the overall balance in the system. So I say to myself, boy, I would like a bunch of points that make balances. So I draw a line